Hello students, I am Mrs. Anuradha Desai. Today we are going to learn how to calculate oxidation state of the metal ion in coordination complex. To understand this calculation, we need to know the charge present on the ligands. Here in this chart, I have given you a list of anionic ligands and neutral ligands. Let's go through it. My first anionic ligand is bromide, charge is -1. Fluoride, charge is -1. Oxo, the charge is -2. Hydroxide, charge is -1. Cyanide, charge is -1. Oxalate, charge is -2. Carbonate, charge is -2. Acetate, charge is -1. Now let's start with the neutral ligands. As the name suggests, neutral ligands, that means the charge will be always 0. Let's go through the names of this neutral ligand. This is ammonia, charge is 0. Water molecule, charge is 0. Nitrosyl, charge is 0. Carbonyl, charge is 0. Dioxygen, charge is 0. Dinitrogen, charge is 0. Next one is pyridine, charge is 0, and ethylene diamine, again charge is 0. If you get a question like calculate oxidation state of Fe in FeCN6 4 minus, look at this particular complex FeCN6 4 minus, there are no counter ions. Charge number of the complex is -4. Now in the coordination sphere, you will come to know that my central metal ion will be Fe, which is surrounded by 6 cyanide ions as ligands. So my answer will be, first step, I am going to write the formula, that is charge number on complex ion is equal to oxidation state of Fe plus charge of ligand. Now I'm going to substitute the values. I know the charge number on complex ion will be -4. Oxidation state of Fe I'm going to calculate, so it will remain as it is. Charge of ligands. Now I'm going to write 6 multiplied by charge of Cn minus ion, because I know that 6 ligands are present, and which are my ligands? Cn minus ions. Now next step will be -4 is equal to oxidation state of Fe plus 6 multiplied by -1, because I know the charge on Cn minus ion will be -1. Now I am going to solve this equation. -4 is equal to oxidation state of Fe minus 6. So it will be, when this -6 will go on this side, it will become +6. So -4 plus 6 is equal to oxidation state of Fe. So obviously the value will become -2. Let's move to the next question. Calculate oxidation state of Fe in FeH2O5 NCS plus 2. Now when you look at this particular complex, you will come to know that there are no counter ions. Charge number is +2. In this coordination sphere, you will come to know that Fe plays a role of central metal ion, which is surrounded by totally 6 ligands, out of which 5 are water molecule and 1 is isothiocyanide ion. Now how to solve this question? Obviously my first step is to write the formula. Formula is charge number on complex ion is equal to oxidation state of Fe plus charge of ligands. Substitute the values. As I know charge number on complex ion is +2, so we are going to write +2 over here. I'm going to calculate oxidation state of Fe, so write it as it is. Now instead of this charge of ligands, what I'm going to write? 5 multiplied by charge on water molecules plus 1 multiplied by charge on isothiocyanide ion, because how many ligands are present? 5 water molecules and 1 isothiocyanide ion. Now next step will be plus 2 will remain as it is equal to oxidation state of Fe plus 5 multiplied by 0, because I know that charge on water molecule is 0. Then 1 multiplied by, I have written minus 1, because I know that the charge on NCS ion will be minus 1. Solve this particular equation. You will get the value of oxidation state of Fe is plus 3. Now let's go to the next question. Calculate oxidation state of CO in Na3CO Na2 6. If you look at this particular complex, you will come to know that counter ions are also present along with the coordination sphere, and that is why no charge number is mentioned directly on the coordination sphere. So my first step is to calculate charge number present on the coordination sphere. Till that I cannot apply the formula directly. So for that I will have to see which counter ions are present and how many counter ions are present. I know that 3 Na plus ions are present as counter ions. So total charge on the counter ions is plus 3, and therefore total charge on the coordination sphere will be minus 3. Now you can apply the formula, that is charge number on complex ion is equal to oxidation state of CO plus charge of ligands. I know the charge number on complex ion is now minus 3. So I'm going to write minus 3 is equal to oxidation state of CO plus 6 multiplied by charge of NO2 minus ions. Why? Because 6 ligands are present which are NO2 minus ions. So minus 3 is equal to oxidation state of CO plus 6 multiplied by 1, because charge present on NO2 minus ion will be minus 1. Now solve this equation. You will get the value that oxidation state of CO is equal to plus 3. Now let's start with the last problem of this video. Calculate oxidation state of CO in CONH3 CO3Cl. If you look at this particular complex, you will come to know that counter ion is present along with the coordination sphere. Which counter ion is present? Cl minus ion is acting as counter ion. How many counter ions are present? Only one counter ion is present. So total charge on the counter ion is minus 1, and therefore total charge on the coordination sphere will be plus 1. Now I can write down the formula, that is charge number on complex ion is equal to oxidation state of CO plus charge of ligands. I'm going to substitute the values. Plus 1 is equal to oxidation state of CO plus 5 multiplied by charge of ammonia plus 1 multiplied by charge on carbonate ion, because 5 ammonia molecule and 1 carbonate ion is acting as ligand. Now next step will be plus 1 is equal to oxidation state of CO plus 5 multiplied by 0, because I know that ammonia molecule is a neutral ligand, charge will be 0, plus 1 multiplied by minus 2, because I know that the charge on carbonate ion is minus 2. Solve this. You will get the value of oxidation state of CO is plus 3. In this video, we have seen how to calculate the oxidation state of metal ion in coordination complexes. This concept is also useful for us when we are going to start with IUPAC nomenclature of coordination complexes. Thank you.